Today, my guest is Professor Péter Hegyi, who is a very special person in the Hungarian science. You are the organizer of the National Academy of Scientific Education, and today and these days, this organization has the 25th meeting, which is a very special occasion because this means that this is a long-standing initiative, which has its successes because many young researchers are on the field who started their career here. But today is also special because today you participated in this conference not only as an organizer but as a scientist as well. And the occasion for this is that you were awarded with the Pitts Prize, which is the greatest or maybe the greatest prize in physiology. What is this prize about and why were you awarded with this?
Yes, indeed, it was really a special conference for me this year because this was the first time that the students could see me not only as a manager or a director of the program, but also as a scientist. The Pitts Award is one of the most prominent awards of the International Union of Physiological Societies, which is an umbrella association of more than 60 national physiology a society, included the British PhysOc or the Hungarian or the other ones. And they every 4 years award a prize in a couple of categories, which is one of them the Pitts Prize. And they just award it in every 4 years for a scientist. And actually, when I got the email that I received the Pitts Prize, at first I thought it's a spam because I didn't believe that that I received it. And after they send it again, and when I read it, you know, it was written that very specific reason what we discovered in pancreatology concerning the physiology and pathophysiology of bicarbonate secretion. And when I looked at who received the prize earlier in every 4 years, I found names which are unbelievably recognized ones, like Walter Boron, who is like, we learned physiology from his medical physiology textbook. He was the former chief editor of Physiological Reviews, the #1 physiology journal in the world, or Dennis Brown. I was actually in Birmingham in 2013 when he received the prize. He is the current president of the American Physiological Society, and he also acted as chief editor of Physiological Review. So being among these great scientists on this prize list, it was really a tremendous honor for me.
And have you received the prize because of your results in basic science?
Yes, it was due to the understanding the physiology and pathophysiology of bicarbonate secretion. We asked a very simple question in pancreatology that why the pancreas secrete the bicarbonate, because it's a textbook knowledge that the stomach secretes acid which go into the gut, and the pancreas secrete the bicarbonate in order to neutralize the acid in the gut. But we ask the question then, why the pancreas secrete the bicarbonate and not the gut? If you need to neutralize the acidic chem in the gut, then why not the gut epithelial cell secretes? And there was a long 25 years experiments when plenty of results built to each other, and actually one of the major idea came from a UK physiologist, an Australian physiologist, who had nothing to do with the duct cells, but he was the very first who described that acinides secrete acid. And what we did actually, we did several experiments, and to make the long story short, the final understanding was that the pancreas secretes the enzymes in an inactive form, not to allow them to eat, to digest the pancreas, and secrete it to the gut. And there are enzymes which activating in the gut. However, if the context, the surroundings are acidic, the autoactivation of trypsinogen tremendously grow. So the pancreas secretes the bicarbonate to defend itself from autoactivation of trypsinogen. This was a completely new theory in physiology. And I think the second part of the prizes came from the pathophysiological relevance of bicarbonate secretion, because we identified the channel who is responsible for plenty of pancreatic diseases, the CFTR, which is actually a chloride and bicarbonate channel. And if the genetic diseases of this channel cause the cystic fibrosis disease in children, and we identified that this channel is not only can cause disease as a genetic background, but almost all pancreatitis-inducing factors, a strong inhibitor of CFTR. So we proved that pharmacological inhibition of this channel can cause pancreatitis. And the third major point, which was the reason for the prize, was that we not only showed that the damage of the CFTR actually can cause disease, but the currently available CFTR correctors and activators can restore the CFTR function. So it's a new therapeutic possibilities in pancreatitis. So there's a big hope that we can find the first specific therapy in the disease. So these 3 points were the one, I guess, and it was written down, that the IUPS believed that these discoveries in the pancreas is unique, and it first awarded the prize. Of course, I was still very much impressed, and I still believe that plenty of other scientists could have been awarded, but it's still an honoring thing.
Yeah, it's clear that it has a very strong importance in practice, and you are also a clinician, not only a basic researcher. And there is a strong interplay between basic science and clinical science in your career. And you are the founder of the Translational Medicine Research in Hungary. Why do you think that this is a very important direction in science, to do translational medicine?
I think one of the, I would say, most common mistakes or bad thinking were concerning physiology and medicine, that people felt that either you do physiology or pathophysiology, or you do basic science, or you do clinical science. And in the past it was quite obvious. If you look at the Nobel Prize, it's written physiology or medicine. And this was quite thinking in the past. You either go to a basic scientist or a clinician. And actually what's happened then, year by year, when more knowledge came to science, it was very obvious that there will be a huge barrier between the thinking of physiologists and the thinking of physicians. So you need to translate information between them. And it's crucially important to mention that, like most of the Nobel Laureates, actually in physiology or medicine, should have been awarded not physiology or medicine, but physiology and medicine. Like in this meeting, Sir Robert Ratcliffe, azt hiszem ezt meg lehet vágni.
Meg, biztos.
Today, our guest, or for example, the 25th anniversary meeting this year, actually our guest is Sir Péter Ratcliffe from Oxford, who is still practicing a medical doctor. And he always went to seeing patients and doing science. And actually it's very clear that if you ask the question at the patient side, go to the laboratory, find the answers, going back, you can make it in medicine. For example, he asked a very simple question, how the kidney cells sense and adapt oxygen. And he immediately realized that not only the kidney cells doing it, but the whole body cells, so change the whole physiology thinking on hypoxia. And he not only did it, but he moved the field to the way that currently there are treatment in anemia based on his discovery. And I can tell stories by Bruce Beutler, who also visited us, and concerning he received the Nobel Prize for discovering the cohectin, which is the TNF-alpha. Now everybody knows in medicine how many drugs are acting on this target. So what we realized, that those discoveries, which actually made by physiologists and scientists and physicians together, so physicians, scientists, then the results are very much translatable to the patient's bed.
You are the founder of the Translational Medicine doctoral program, which is very successful. It has several PhD students from Hungary and different countries. And do you see similar success stories from the researches of PhD students that might be perspective in the future? Because this program has some year history. So maybe there are some research stories that were published, and it seems that this will be successful in clinical aspects as well.
First of all, I would like to mention that we didn't find out really translational medicine, and actually translational medicine, it's all around us. Mm-hmm. So we just looked at the history very carefully and looked at the success stories, how it was made. The best example is Ignaz Semmelweis, who was in Vienna in the 19th century, in the second part, and asked an easy question, a simple question: why gynecology and obstetrics institution mothers die more often during birth than in the others? And this was like 10% in one of the institutions, the other is 1.5%, 2%. And he collected data. After he collected data, he understood the difference. He actually put up a hypothesis that in the clinic, that the mother's mortality were 10%, the doctors came from autopsy, and after actually examine the women, so therefore they transferred something from autopsy to the women which caused the death. He put a hypothesis that if we use chlorinate and wash our hands, actually this will remove the toxic factors which are taken from autopsy to women. And he did actually a prospective study. At that time, nobody called it prospective study, or there were even not names for the study types. And he immediately proved that not only he could decrease the mortality in the first clinic of gynecology, but in both clinics it dropped down. He asked a very simple question, did the data analysis, and immediately provide evidence to save millions of lives. So this is translational medicine. So based on actually his practice, we did exactly the same from 2016. And as you ask, yes, we have now direct evidence that we could repeat the success of Semmelweis. So now in this program, where we have 440 PhD students, there are many, like a grandchild, or I don't know how to say, like followers of Semmelweis Ignaz in all over the field of research, right? I can mention like a gastroenterologist who came to the program and asked the simple question: why do we use antibiotics 80% in patients in pancreatitis when it's an inflammatory disease? And she not only answered this question and find the reasons that we misunderstand the inflammatory markers, but she went back to the hospital in year 2, applied it, and she could decrease, like Sengyörgyi did in mortality, the usage of antibiotics with 31%. And very interestingly, she defended her PhD a year later. So her individual benefit came later than the benefit of the society. And I can tell these kind of stories many. So this is what I most enjoy the translational program, that in this program the patients heal earlier than the individual academic benefit comes to the doctors.
So the secret behind these success stories is to have a good question and to do research with good methodology. Am I right?
Yes, I mean, if we look at what science means, it's the same like from Newton to drop the apple. So the main issue of science that is completely independent on anything. So if you drop the apple in Budapest or in London or in Tokyo or anywhere in the world, it's acting the same way, irrespectively the political nature of the country, irrespectively the weather and anything. So science must be reproducible. So science means you have a question and you have a very rigorous methodology. You collect data in this way, and after you get the results, interpret and use it in practice. And the major issue is that if somebody read your paper and repeat the methodology part you put it on, they must get the same result.
I know that you are obsessed to attract young people to science, to medical science, to life sciences, and maybe it is the reason why you established the National Academy of Scientist Education, which is a very successful story as well. Why do you think it is important to show science, how science is working for young people?
What we can see worldwide, from Asia to US to Europe, that the interest for science in youngsters, in high school students, is decreasing. And I think one of the main reasons that science must be for everybody. And it's very common that scientists doing their jobs in the laboratories next to the patient's side. And this is like in an island, and they don't show to people what does it mean, how the questions arose. So the students at high schools, they don't even know what does it mean, science. If you ask general people, what do you think about a scientist? Please draw a scientist. Everybody actually drawing, you know, a scientist, not like me, like with a big hair, you know, sitting in front of a microscope. So they believe they are crazy people who actually serve science. But science is everywhere, in every people. So our major aim to bring out science from the laboratory to high schools, science from the laboratory for public, science for everybody. And when they understand that the science is not like something for crazy people, but it's a very easy thinking mindset you are using, they realize that they like it. It's the same like in football. If you want to understand somebody likes football or not, give the ball to her or him, kick to the net. If it's enjoyable for you, then let's come to be a footballer. This is our aim in science. Invite the high school students, come to this program, challenge yourselves, do it by yourself, learning by doing, and if you like it, stay with us and we will help you. I don't know it's success or not. What I think it's very, very valuable.
It seems that it's successful because this meeting had a record attendance, more than 4,000 young students, or maybe more.
Yeah. Thank you so much. I also see the success, but for me, success is always, you know, a question, especially for myself, because my character is I always see the empty seats and the forthcoming challenges. So I don't think so I ever will be satisfied in my life what we achieve, because I can see the next steps we can go forward. But what is sure that we made something very valuable, because the future of each country and even globally, internationally, the human actually is from the fact that how many young people join to science. It's very easy to say for general people that we wouldn't even have fire if we would have no science. This is very clear. So as many as people will think, while the past people think how to make fire, if you have 10 times more people, the advances for human being will be 10 times faster.
Thank you. Thank you for this precious message. Congratulations for the award and also for this very successful meeting. Thank you, Peter, for the interview.
Thank you very much.
Thank you.